Hey guys, sorry about that. I guess that was definitely the wrong video that I sent you because you've already learned that. Hopefully, well, I guess I can't even use it for Callan because I have a weird face mask and that's kind of weird. Alright, so let's look at lesson number 11 from module 4. This will hopefully actually be the correct examples. So example number 1, it says use the model to answer the following question. So here's our model. How many 5s are in the model? 1, 2. 2. How many 3s? 2. What expression, or what does the expression represent in words? So here we actually have to start thinking. Alright, so what does this expression, it's the sum of two groups of 5 and the sum of two groups of 3. So the sum of two groups of 5 and two groups of 3. What expression could we write to represent this model? We could write 2 times 5, actually I'm going to do my dot, 2 times 5 plus 2 times 3. And we don't have to do parentheses because we know we multiply before we add. So let's use, well, that's it. All right, so let's look at the next one. Use this new model to, and the previous answer, or previous model to answer the next set of questions. So how many 5s were in this model? Oh, sorry. I forgot to draw this one, sorry. So this next model looks like this. So we have 5 and 3 and 5 and 3. All right, so now we've got 5 plus 3. 5 plus 3. How many 5s are there? 2. How many 3s are there? 2. So this expression would say two groups of the sum of 5 and 3. So for this, I could write 5 plus 3 plus 5 plus 3. I do need parentheses so that I add just those parts at first. Or I could say 2 times 5 plus 3. Both of these ways would be acceptable ways to represent this model. So is the model in part A equivalent to the model in part B? Yes, because they both have 2 5s and they both have 2 3s. So because of that, I now know that 2 times 5 plus 2 times 3 equals 2 times 5 plus 3. We just proved that this is true. So what relationship do we see happening on either side of the equal sign? On the left side, we see 2 being multiplied by 5, and then 2 being multiplied by 3. And then we add the products together. And here we add them, and then we multiply them by 2. So we're seeing that, that's what we're seeing. In grade 5 and in module 2 of this year, we use similar reasoning to solve problems. What is the name of the property that is used to say that 2 times 5 plus 3 is the same as 2 times 5 plus 2 times 3? Well, if you remember, the name of this property is called the distributive property. Distributive property. That's something you learned in 5th grade. That's something you learned in the 2nd module this year. Distributive property. All right. Let's look at example number 2. So now we're going to look at examples using variables. So it says discuss with your partner. You don't have a partner. That's fine. And you're not discussing. You're watching a video. So some things are a little bit different than how this lesson was intended. And you know, we're just going to deal. So what does this model represent inwards. This one is looking like this. So 2a means that there are two a's. So this is a plus b plus b. So 2 a's plus 2 b's. Or 2 times a plus 2 times b. Got a lot of different options. So what does 2a mean? That means there are 2 a's, or 2 times a. How many a's are in the model? 2. How many b's are in the model? 2. All right, what expression could we write to represent the model? Well, we could write 2a plus 2b. Actually, I'll write that on here. 2a plus 2b. And that's going to be the best expression we can write here. All right, let's look at this next one. A plus b. So how many a's are in this expression? 2 again. How many b's are in this expression? 2. What expression could we write to represent this? We could do a plus b plus a plus b. Right? So are these two expressions equivalent? Yes. Both models include 2 a's and 2 b's. So therefore, 2a plus 2b equals 2 times, I can rewrite this as 2 times a plus b. These are all equal to each other. Again, distributive property. So exciting. All right, example number 3, use GCF, that's the greatest common factor, and the distributive property to write the equivalent expression. So, number 1 is 3f plus 3g. We can rewrite this as, so equals 3 times fg. Just like that. F plus g, sorry. 3 times f plus g. That makes more sense because f and g are not being multiplied there. So 3 times f plus g. What is this question asking us to do? We need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as the product of factors. The number outside the parentheses is the greatest common factor, so they both have this greatest common factor of 3. Okay? So how would we rewrite this? If we wrote it in expanded form, we would say 3 times f plus 3 times g. That's what we were working on yesterday. And what is the greatest common factor here? The greatest common factor is 3. So how can we use that greatest common factor to rewrite the expression? 3 goes on the outside, and the f plus g goes inside the parentheses. All right, well, let's look at this second one, because the second one might be a little bit different. We've got 6x plus 9y. Here is where that greatest common factor comes in handy. So we need to figure out what the greatest common factor they both have is. So they're both, 6 and 9 are both divisible by 3, right? So I'm going to put 3 on the outside of the parentheses. So 3 times how much gives me 6? 2. So we have 3 times 6x plus 3 times how much gives us 9? 3. 3 times 3 is 9. So 3 times 3y would give me 9y. So here, if I rewrote this problem, again, the greatest common factor is on the outside. So if I rewrote the problem in expanded, it would look like this. 2 times 3 times x plus 3 times 3 times y. That's our expanded form. The greatest common factor here is 3. So I can use that 3 and then work on just the other parts. The other parts are what's inside the parentheses. So that 3 goes here and the rest go there. Number 3, we get 3c plus 11c equals. Here, the greatest common factor is not a number that you know of. 11 and 3 don't have a common factor, but they do have a common factor here. 3C and 11C have a common factor of C. So in this case, we've got C times 3 plus 11. So if I wrote this in expanded form, you would see it's 3 times C plus 11 times C. And we see this C comes in handy here. So that's why it's there. And then we do the 3 plus 11. So 3 plus 11 is being multiplied by C. That's why we write it that way. Almost done. Only one problem left. It's 24b plus 8. 24b plus 8. Ooh, that 8 doesn't have a variable, but that's okay. So I'm going to first look at expanding each term. But I do see already 24 and 8 have a common factor. The greatest common factor between those is 8. So it's 8 plus, well, 8 times 3 is 24. So 3b plus, and then 8 times 1 is 8. So let's double check though. We'll write this in expanded form. So we get we could do 8 times 3 times b plus 8 times 1 would be kind of expanded, but I want to make this as expanded as possible. So let's take this 8 and expand it more. You get 2 times 2 times 2 times 3 times b plus 2 times 2 times 2 times 1. That's kind of what that ends up being. So the 1 is in the parentheses because when you factor out a number, you're leaving behind the other factor. So because 8 times 1 is how we get that 8, we have to have this 1. So we're doing 8 times 1, which gives me 8. And then we're doing, I'll show you here, 8 times 3b, which gives me 24b. So that's how this works out. That's why they're equivalent. Okay? You don't have to answer all the questions on there because they're questions, I think, lead it to be more confusing than it needs to be. So now you're going to do your exercise. You don't have to do the problem set. You only have to do the exercise. And you also don't have to do the closing questions. So just the exercise is plenty for you today. If you have any questions about how this math works, please let me know. I am here to help. Have a great rest of your day.